Hello, and welcome back to our channel. Today, we will be talking about organic chemistry, particularly alkanes, and its properties, structure, formula, and reactions. Before we start, make sure to like, comment, share, and subscribe so you don't miss any of our fun educational videos. First of all, what is organic chemistry? Organic chemistry is a branch of chemistry that focuses on the study of carbon-based compounds, typically involving carbon-hydrogen, CH, bonds. It was originally confined to compounds produced by living organisms, but now extended to include man-made substances based on carbon, such as plastics. Carbon is unique in its ability to form long chains and complex structures through covalent bonding, allowing for many organic compounds to exist. Now, what are alkanes? Alkanes are hydrocarbons. A hydrocarbon is a compound that is made of only carbon and hydrogen. Alkanes can only form a single bond between its carbons, unlike other organic compounds such as alkene and alkynes, which are explained in another video. The general number formula for alkanes is CnH2n plus 2. Say, for example, you have 44 carbons in an alkane, and you want to figure out the number of hydrogens without drawing the whole structure to count. You would sub 44 for N, and your formula would become C44H90, which would be very complex to name. You could also use this formula to verify that you drew the right amount of hydrogens for each carbon in structural drawings. The suffix of alkane is -ane, which is added to a word before it depending on the number of carbons. Now, what are the names for alkanes? The names for alkanes depend on the number of carbons. If you have 1 carbon, the name will be methane. If you have 5 carbons, the name will be pentane. Here is a table of alkanes with 1 to 10 carbons. As you can see, the names are basically the prefix of the number that ends with -ane. Now, how do we draw these organic compounds, you may ask? Well, it's much simpler than you think. There are 3 different ways of drawing an organic compound: structural diagram, condensed structural diagram, and line diagram. A structural diagram shows each single atom bonded to another atom. To start drawing any compound, always start with drawing the carbons, then proceed to fill the rest with hydrogens. Remember, each carbon can only have up to 4 bonds. In alkanes, carbons in the beginning and in the end of the chain will be attached to the next carbon and 3 hydrogens. Carbons in the middle of the chain will be attached to the 2 carbons beside it and 2 hydrogens. Alkanes only have single bonds, which is why it's the simplest organic compound in organic chemistry. So if you are ever drawing or naming an alkane, you don't have to worry about naming double and triple bonds. Now let's talk about more complex alkane naming and drawing. You have seen the alkane parent chains of the first 10 carbons, but compounds are not this simple. You will often get diagrams with extra branches. These branches are called alkyl groups. Here is a chart of the alkyl groups. Let's see a couple of examples of diagrams to demonstrate each step on how to name them. Let's look at this one right here. It's a line structure of an alkane. First, we have to find something called the main chain, which is basically the longest chain of connected carbons that you can find. So over here, it looks like the longest chain will be made out of 5 carbons. Next, we look for any branches, so we have a methyl group branched at carbon number 3. Now, to name any organic compound, you always start with the end that is closest to the first branch, and if you have multiple branches, choose the side that will make the numbers the lowest possible. For this example, whether we start from the right or left, carbon number 3 is in the middle, so it doesn't matter where you start numbering. Now, to name it, we always start with the number that shows the position of the branch, sometimes a compound, which we will get to later in other examples. To separate numbers, use commas. To separate a number and a letter, use a hyphen, so we write the number 3, then hyphen, then we write the name of the branch, which is methyl, and lastly, since we only have 1 branch, we write the name of the main chain, which is pentane. So this alkane is called 3-methylpentane. Let's see another example with more than 1 branch and other elements. In organic compounds, you can have elements such as bromine, chlorine, iodine, and fluorine bonded to the carbons. Alkanes with halogen elements are called haloalkanes. You can also have functional groups, which are explained in another video as they are different from alkanes. So let's say you have this alkane, and remember, you can tell it's an alkane since it has no double bonds or any functional groups other than alkyl branches or elements. So first, let's start by finding the longest chain. Since this is a straight zigzag chain with only a branch or 2 at a carbon, you can easily tell it's the main chain. Now, how would you number this? The right side will give you position numbers 1, 3, 5, and 7, while the left side will give you position numbers 2, 5, 6, and 8. Obviously, numbering from the right side will give us lower numbers, so we will go with that. Next is naming the branches in order. So to indicate where a branch is, you always put the position number then hyphen then branch name. But when there are multiple branches, you start alphabetically. B comes first in the alphabet, so bromine will be first. Bromine is attached to carbon number 1 right here, so it's 1 bromo, then we have chlorine next. But notice we have 2 chlorines at the same carbon. So we write 7,7, dichlorine. The 2 7s show that both chlorines are at carbon number 7. The D in chlorine shows that there is 2 chlorines in the entire compound. Next we have an ethyl at carbon number 3, so we write 3-ethyl. Then we have 2 methyls that are at carbon number 5, so it will be 5,5-dimethyl. Lastly, we indicate the name of the parent chain. Since there are 8 carbons and it's an alkane, we use octane. So the name of this alkane is 1-bromo, 7,7-dichlora, 3-ethyl, 5,5-dimethyloctane. What about drawing? Well, drawing is the easier portion. Let's say you have a compound like 3,4-dichloropentane. First, we look at the name of the parent chain in the end, which is pentane. So we draw pentane. Then you count from 1, 2, 3, and here you attach your first chlorine. Then on the next carbon you attach the second chlorine. Always start with the parent chain when drawing an organic compound. The last thing we will be talking about in this video is cyclic structure, also known as cycloalkanes. Cycloalkanes are alkanes that are organized in a cyclic structure so that carbons end up connecting to each other. Here are the cyclic structures and names. The smallest cyclic structure is a cyclopropane, which has 3 carbons that form a triangle, since of course 2 carbons or a carbon cannot form any cyclic structures by themselves. Let's see a few examples. How would you name this? Well, just like before, you would want to number it to have the smallest position numbers possible. So would you start with the ethyl or fluorine? Since ethyl comes first alphabetically, we will start with ethyl, so 1, 2, 3, and 4. Just like before, we write 1-ethyl-2-fluoro. Since it's a cyclic structure, we then write cyclo, and then the parent chain name, which is butane. So this compound is called 1-ethyl-2-fluorocyclobutane. For drawing a cyclic structure, it's the same process. Let's do an example. Say we have 1,3,4-trichlorocyclohexane. First of all, we know the parent chain is cyclohexane, so we draw a hexagon. Next, we have 3 chlorides, so you can start the chlorides wherever you want as long as it follows the same position numbers. So I will put the first chloride here, then we have no chlorides at carbon number 2. So I skip to carbon 3 and 4 where they both have chlorides, and here you go, nice and simple. That's it for alkane naming and drawing. We hope you all enjoyed this video and learned something. Don't forget to like, comment, share, and subscribe. We hope to see you in our next video. Bye.